Zinc nickel is a cadmium alternative that is 10 to 14% nickel, and the balance of the composition is zinc, and it is used for corrosion resistance. The biggest advantage for zinc nickel to replace cadmium is the performance benefits, and it is a direct drop-in replacement process for the cadmium plating process. The technology for that process does not need to change at all, and due to the high efficiency of the zinc nickel, it lends itself to very low hydrogen embrittlement. The cadmium is being replaced due to the environmental and health risks posed to the operators and the environment itself. Zinc nickel was initially developed in the early 90s and approved by NASA in 1992. Due to the environmental and safety issues posed by cadmium, Boeing and NASA were the first to adopt its use in production and repair. Because of cadmium's negative impact on the environment and operators, the military, aerospace, automotive, and nuclear industries are all preparing to use zinc nickel or other cadmium alternatives in the future.
Industry specifications have been written for the zinc nickel process. Currently, there are 3 specifications, which include AMS 2417, AMS 2451/9, and Boeing's BAC 5664. Sifco ASC offers solution code 4018, which is certified to the requirements of the noted specifications.
As we've said before, zinc nickel is seen by industry as a viable alternative to cadmium. The purpose of this video is to demonstrate the proper application of zinc nickel using the Sifco process of selective plating to achieve a deposit that meets the performance requirements of AMS 2451/9 and BAC 5664. As with any chemical process, it's important to use personal protective equipment. In this case, chemical-resistant gloves, safety glasses, and to have good ventilation. The plating tool selected for this demonstration is smaller than would normally be used to show the appearance of the deposit as it's being plated. The primary objective of any selective application is to apply a uniform and adherent deposit to the calculated thickness that's applied in accordance with the specification requirements. When plating on parts susceptible to hydrogen embrittlement, an abbreviated preparatory procedure is used, starting with a degreasing operation, followed by a roughening up of the surface by blasting or mechanically abrading, and then rinsing to ensure all foreign materials have been removed, and then finally plating. The part being processed is a high-strength steel coupon that will be used for salt spray testing. The part was solvent cleaned, masked, and then placed into the holding fixture for plating. The part's mechanically abraded with 120 grit aluminum oxide paper to roughen up the surface. It's rinsed thoroughly to remove any particles and then plated. Note that the saturated plating tool is applied to the workpiece with current. Saturated anode is moved uniformly over the part, and in a very brief period of time a visible layer of nickel is deposited. The anode's repeatedly dipped into the fresh solution every 7 to 10 seconds, and then continuously moved on the part until the calculated amp hour value to achieve the deposit thickness of 5/10,000ths of an inch has been reached. It's important to note that the specification requires that only fresh solution be applied to the part. That is, the solution should not be recirculated or reused when hydrogen embrittlement is a concern. Note that even with the use of fresh solution, only very minimal waste is generated with the process. After plating, the part's rinsed thoroughly with deionized water, and the trivalent conversion coating is gently applied to the surface using a squeeze bottle. The surface is kept saturated for 2 minutes, after which the part's gently rinsed with deionized water and then allowed to air dry. It's important to note that the surface with the conversion coating is very fragile while wet and should never be wiped or dried with compressed air. Once the part's completely dry, it'll be placed in a salt spray cabinet for 96 hours. Although some brush plating repairs to aircraft components are done in situ on the aircraft, many are done in the shop as components are being reworked. Because the components have been in service, it's important to ensure that they're properly cleaned to remove any grease or oil from the surface to be plated, as well as any adjacent areas. So this is a typical brush plating repair done prior to installing a new bushing on a torque link for a main shock strut. After solvent cleaning, the part's mechanically abraded with 120 grit aluminum oxide to roughen the surface. The diameter is thoroughly rinsed with deionized water. Note that no masking is required for this application since the paint on the areas adjacent to the bushing diameter serves as a mask. The conforming anode's wrapped with cotton batting and sleeving. It is thoroughly saturated and the initial contact with the part is made with current. The anode is moved around the circumference of the part to ensure a uniform deposit thickness. It's resaturated every 10 to 15 seconds. The process is repeated until the calculated amp hours have been passed to apply a minimum of 5/10,000ths of an inch thickness. Using an anode with the optimum contact area, the plating time to apply this thickness is around 3 minutes. As noted previously, for an LHE application following BAC 5664, the solution is not recirculated or reused. After plating, the part's thoroughly rinsed with deionized water. As you can see, very little waste is generated with this operation. For an area of this size, typically less than 100 milliliters of waste is generated. And the conversion coating is applied by using a squeeze bottle to gently flood the area and keep it wet for 2 minutes. Conversion coatings are very fragile as they form and should never be wiped or brushed during the application. Note that the conversion coating is captured to be recycled. After 2 minutes, the part is rinsed with deionized water and allowed to air dry. Keys to success for a selective LHE zinc nickel repair application are carefully planning how the operation will be carried out, gathering the necessary tooling and equipment, setting up the job and masking as needed to manage the minimal solution runoff, thoroughly cleaning the part before and after abrading, and then plating the part following the written procedure that uses the optimum processing parameters.
Zinc nickel has been proven to give more than 500 hours of salt spray protection when used with a trivalent chromium conversion coating, presenting a more environmentally friendly solution to the market, which is just as reliable and effective as cadmium. The use of a high-performance, non-hex chrome clear passivation further increases protection of zinc nickel against rust to double the duration achieved without a coating. Zinc nickel is the leading cadmium alternative on the market, with multiple industries already preparing for the change in their process. It is imperative that the application of the deposit and subsequent conversion coatings are applied in accordance to Sifco's technical data sheets. For more information, visit us at sifcoasc.com or contact us at 800-765-4131.